All right. The principle, just making sure. The principle of conservation of energy states the following. This is number 2. Energy can neither be created nor destroyed. It can only change form. That's it. Now for part B. I saw a lot of people writing about forces. Let's be really clear. This principle needs to be explicitly used for part B when they say use the principle of conservation of energy. So I'm going to be very careful about that here. So, starting from rest, the energy, energy in the plane is actually stored as chemical energy in the fuel. This is converted into kinetic energy, the plane moving, as well as heat energy, and sound energy, and dissipated energy, the ground. So again, only talk about energy, don't mention forces. Okay, so here. Part C. The average resultant force on the aircraft while traveling along the runway is 70 kilonewtons. So that's 70,000 from the data booklet. The speed of the aircraft just as it lifts off, 75 meters per second, estimate the distance traveled along the runway. Once again, we've got a force, we've got a speed, we want a distance. And this is the classic, if you're skidding or you got an airplane taking off, I'm going to use work is change in kinetic energy, but I need to write it like this. Force times the distance is 1/2 mv squared minus 1/2 mu squared. U is 0, so that we can just eliminate. So we've got 70,000 newtons times our distance d equals 1/2 times 8,000, that's from here, times 75 squared. And when I get that distance, it actually ends up being 320 meters. Here. Now for this potential energy, E potential, it's height, so mgh, that's going to be 8,000 times 10 times a height of 1,250. And the result that we're going to get is, I don't write it their way, they would say 100 megajoules or 100 million joules. Any way you want to write it. All right, next question. Okay, we've got something moving in a circle. People wrote a lot of stuff. We've talked about this in class. Please memorize this fact. The force is directed towards the center of the circle. That is it. Okay. Now we want the force on the aircraft. That is F is mv squared over r, which is going to be 8,000 times 90 squared divided by 500. And when we actually get that force, just see, we end up getting 130,000 joules, or if you prefer, 130 kilojoules. So, yes, that is it for problem number